Okay, ladies. The name of this game is Quick. Trying to make the video quickly. So I have been editing everything. Gonna go fast. In class, we talked about, I hope, cotangent and cosecant and their definitions related to tangent and secant. So cotangent of theta, that's equal to the cosine of theta over the sine of theta. And the cosecant, abbreviated CSC, the cosecant of theta, that's equal to 1 over the sine of theta. So what I need you to understand, without going through a lot of explanation or a lot of deriving, is that these values are the exact same values of tangent, just in different positions, and these values here are the exact same values of the secant, but also in different positions. So if we take a look at the unit circle, we've got, say, the cotangent of pi sixth. Instead of doing sine over cosine, we would do cosine over sine, and the cotangent here would be root 3. The cotangent here would still be 1. The cotangent here would be 1 over root 3, or root 3 over 3. The cotangent here would be 0 over 1, or 0, and the cotangent here would be undefined. If we think about the tangent line being a vertical tangent line right here, you can think of the cotangent line as a horizontal line that's tangent to the circle right here. And just like the tangent line, we would connect the middle of the circle to our angle and see that this hits further out. This would hit lined up right there with a value of 1. This would hit more shallow, the smaller value of root 3 over 3. This would hit at 0. This would hit back here. That would be a value of negative root 3 over 3. This would hit a value at negative 1. And this would hit a value way out here at negative root 3. If we tried to take the cotangent of pi, we would get undefined. Good? Hopefully you can see that the cotangent of pi thirds is the same as the cotangent of 4 pi thirds, and they're both a value of root 3 over 3. 7 pi 6 has the same cotangent as pi 6, which is root 3. Good? With the cosecant, it'd be similar, the reciprocal of the sine, undefined here. The reciprocal of the sine, 2. The reciprocal of the sine ends up being square root of 2 when we simplify here. Reciprocal of the sine, 2 root 3 over 2. And again, reciprocal of the sine is 1. And then we see the same thing over here. These are all positive, so it would still be 2 root 3 over 2. Or sorry, 2 root 3 over 3. 2 root 3 over 3. My apologies. Here, this would be root 2, this would be 2, and this would be undefined. Down here is where they would be negative. This would be negative 2, this would be negative 1, this would be negative 2 root 3 over 3, 0, negative 2 root 3 over 3, negative 1, what am I saying? Negative 1, negative root 2. My gosh. Negative root 2, going too fast, and negative 2. Good. All of those values there are the cosecant of special angles. All right. Similar to the last video, there are now 3 Pythagorean trig identities that I want you to know. So, the Pythagorean trig identities, those come from the Pythagorean theorem, right? What a surprise. Take a look here. We've got, a right triangle, right? A squared plus b squared is c squared. So if we take a look at that, remember with the unit circle, we can build in this right triangle where the hypotenuse would be the radius of the unit circle. Our angle theta would be here. This ends up being the sine of theta, and this ends up being the cosine of theta. And you have sine squared theta plus cosine squared theta equals 1. It's called a Pythagorean trig identity because it's the sides of a right triangle in the unit circle. Good? There is, if we divide this by cosine squared, divide this by cosine squared, divide this by cosine squared, we get the one we talked about the other day. Tangent squared theta plus 1 equals secant squared theta. I like this one because the tangent is undefined and the secant is undefined in the same place. The last one, divide this by sine squared and get 1. Divide this by sine squared and get cotangent squared theta. Divide this by sine squared and get cosecant squared theta. These three equations we need to memorize. They are called the Pythagorean trig identities. To them you could add the following definitions. Sine of theta equals opposite over hypotenuse. Cosecant of theta equals hypotenuse over opposite. The cosecant of theta equals the reciprocal of the sine of theta. You could rewrite that and say the sine of theta is the reciprocal of the cosecant. Good? And we should be able to do that for the other 4 trig functions. So we've got that the cosine of theta is equal to the adjacent over the hypotenuse. That the secant of theta is equal to the hypotenuse over the adjacent. That the secant of theta is equal to 1 over the cosine of theta, and that the cosine of theta is equal to 1 over the secant of theta. And last but certainly not least, the tangent of theta, that is equal to the sine over the cosine. It's also equal to the opposite over the adjacent. Okay, the cotangent of theta, that's equal to adjacent over opposite. It's also equal to the cosine of theta over the sine of theta. This is equal to the sine of theta over the cosine of theta. And those are also reciprocals of each other. The tangent of theta is equal to 1 over the cotangent of theta. The cotangent of theta is equal to 1 over the tangent of theta. Good. Your job tomorrow in class, or Monday, well, not Monday, co-curricular day. The next time we have class, your job is to be able to put all this together and be able to find the sine, cosine, tangent, secant, cotangent, or cosecant of any special angle and know all of these definitions. I didn't mean to mark that, but I just underlined it. But yeah, we're all good. Okay, short video, not the most coherent. I hope you enjoy it. Peace.